Whew. I was on a phone call and I switched gears. I apologize for that first few minutes or a few seconds. I see we got David Engelhart in the house, and hopefully good ETZ afternoon. All right, so I don't know about all of you out there, but I was having a little bit of problem with NFPA link. Anybody out there having problems with NFPA link? Let's just try. Oh, I know what it is. There we go. Oop, sorry, I just had to. Hey, Brian Bowman in the house. You are the man. I was having some issues with NFPA link. I don't know. Let me just try this. Whoop. Wrong button. Nope. That's not working. Let me plug this back in again. All right. So, wait, we're talking back on track. Welcome to another IAEI News Live. My name is Thomas Dimitrovich, and today we're going to be talking about ground fault protection of equipment, and we're going to review what is GFPE, where is it required, how does it get done, and all that jazz, and it all starts now. All right. Sorry about that. I'm a little bit disheveled right now. Eastern time zone. Excellent. That helps me. All right. So NFPA link seems to be hung up. I don't know. I've tried 3 different computers and I can't. It says there was a problem logging me on. Anyway, it is what it is. So let's talk a little bit about, hey, we got Fred B in the house. Let's talk about ground fault protection of equipment. And some people I know call this ground fault equipment protection, GFEP. I know I did for quite some time. I referred to ground fault protection of equipment as ground fault equipment protection. So I would say, yeah, I've got GFEP, where I should probably have been saying you've got GFPE. But in any case, if that is where you're at in some cases, then, you're not alone. All right, we got Joseph Violi, Lou Petrucci, we got Michael Hofkin in the house, and Keith Wilson. Yeah, so thank you, Keith, for confirming. I don't know what's going on with NFPA Link, so if anybody out there from NFPA is watching, I was hoping to use NFPA Link, and I can't. So I would, and I know there is an offline capability, but for some reason, my iPad, I might have it on my computer. All right, so let me just try. No, see, my computer, it doesn't go to my offline edition either. All right, well, it is what it is, but we won't let that stop our progress, because you know what I've got? I got a hard copy of the National Electrical Code. And what I'm going to do is I'm going to put this over here. And if I'm using this, I'm going to need these. So my spectacles. So here's what we're going to do. We're moving on the fly. We're getting on the fly. I'll tell you what, I was just debating with somebody on the phone, and I was almost late for this call. And I'll tell you, I'm going to ask this question. I'm going to ask you a question that is related to the surge requirements in Article 230. And I know it doesn't have anything to do with GFPE, but while I am getting getting things organized, I want to ask you this question. If you read in 230, in 215, Article 215, 215.18, 215.18, surge protection. It says, where a feeder supplies any of the following. So I'm going to give an example where a feeder supplies a dwelling unit. So here's the question, and we were debating this all the way up to I was like, oh, gotta go, bam, hang up. I hung up on him and came over here. And the question is, if you have say a panel board on the outside of the house, a meter breaker example. You got a meter breaker on the outside of the house. You have a feeder that goes, one breaker feeds a panel that's in the garage that supplies power to the downstairs. And I've got another feeder that goes to a panel board in the hallway upstairs that feeds the upstairs of that dwelling unit. Do those feeders supply the dwelling? And would they be required, those two panel boards, one that's in the garage and one that's upstairs, be required to have surge protection based upon 215.18, where a feeder supplies a dwelling unit? A surge protective device shall be installed. So that's the question. Think about it. Use the chat. Let me know what you think. And I am going to take a look at this. So I got to open up a file here, but that was the question that we were debating in my call today. What is today? Today is not January 9th. Today is the 15th. Holy for holies. Jeez, it's the 15th. It's 8:15 and I don't have my folder, so my cloud drive's not working. All right. I'm having all kinds of fun today. All right, there we go. Okay, so let's talk ground fault protection of equipment. And what we'll have to do is, I don't see anybody talking about my feeder. I mean, I think I'm looking at the chat box and I'm not seeing anybody say anything. Does that feeder that goes from my outside panel to that sub panel? I know, Joseph. I'm having a thing. Watch this, Joseph. How was that, huh? Okay, so let's take a look at what is the first step in this process is to have an understanding of what the difference is between ground fault protection of equipment and GFCI. And you know where we go to start our journey is we go to Article 100 in Chapter 1. Because remember, Article 100 now in the 2023 code has all of the terms and their definitions that are in the that are used in the code book. Now, and remember, we can always go if a term that's used in the National Electrical Code is not in Article 100, then you know what we do? We run to Merriam-Webster Collegiate Dictionary, the 11th edition, which is somewhere here. I'm not sure where it's at. Any case, the Collegiate Dictionary. So ground fault protection of equipment is on page 70-42 of the National Electrical Code. And this is what it says. A system intended to provide, and it says a system. Let's look at GFCIs, ground fault circuit interrupters. It says a device. Very interesting. Just the very first portion of the definition. The definition of a ground fault circuit interrupter starts with a device intended, and the ground fault protection of equipment says a system intended. So we know right off the bat that there's going to be a difference in the technologies because one says a device and one says a system. So, a system intended to provide protection of equipment from damaging line to ground fault currents by operating, so it's prevents damaging of equipment. Let's look at GFCIs. A device intended for the protection of personnel. So when I contrast the definition of GFCI with GFPE, one says a device, one says a system, one says protection of personnel, the other says protection of equipment. Now, GFPE continues. Protection of equipment from damaging line-to-ground faults currents by operating to cause a disconnecting means to open all ungrounded conductors of the faulted circuit. It has to open all ungrounded conductors. So what does that mean? If I have a ground to neutral, if I have a grounded system, I have a neutral, I have a grounded conductor, I don't have to open that conductor. This protection, the grounded conductor, I have to open the ungrounded conductor. All right. This protection is provided at current levels less than those required to protect conductors from damage through the operation of a supply circuit overcurrent device. Now, what it says, now, there's no informational note. Ooh, public input. Oh, I'm gonna, oh man, I don't know. I think they're trying to get away from these informational notes, but I think it adds a lot of value. But in any case, ground fault circuit interrupter says a device intended for the protection of personnel that functions to de-energize a circuit or portion thereof within an established period of time. So time is of essence. Within an established period of time. That's a GFCI. GFPE just says, it doesn't say anything about time. It doesn't say anything about time. All it says is disconnecting means to open all ungrounded conductors of the faulted circuit. This protection is provided at current levels. So it doesn't say anything about how much time it takes to clear the fault. GFCIs are introducing within an established period of time. When a ground fault exceeds the value established for a Class A device. So I know two things. I know time is of essence, and the definition says it has to be a Class A device. Now, if I look at the informational note, it says to see UL 943. And it says a Class A ground fault circuit interrupter trips when the ground fault current is 6 milliamps or higher and does not trip when the ground fault current is less than 4. Hence, we say 4 to 6. But there's nothing in the GFPE that indicates a threshold. Willie Snyder, good to see you. Jody Wages, Felix Sandoval. Felix, I'm looking at possibly coming down to Columbia. I'm just saying, brother. I'm just saying. I've got somebody called me yesterday about it was an IEEE, I think it was. There's some opportunities shaking out, and I'm going to be in Costa Rica in a few weeks for a Canina meeting. Brian Bowman, not working on my phone. So Brian Bowman in the house. We got Freddie B, Lou Petrucci. All right, we got a lot of good people online. And we got Jerry. Hola, Jerry. I just asked everybody. Jerry, I just asked everybody on this call, which nobody chatted about the discussion around a service and a feeder that goes to a panel board in the garage that feeds the downstairs, and a feeder that goes to a panel board on the, a hallway upstairs that feeds the upstairs, whether or not those feeders supply a dwelling unit. I'm just saying. Okay, so let's get back to the point of, so we know that ground fault protection of equipment doesn't have any reference to a current threshold, and it does not have any reference to a pickup, a time, clearing time. Now, let's address the standards first. 943 is what we use for ground fault circuit interrupters, right? UL 943. That establishes the clearing times, and we've done programs on this channel that speaks to GFCIs. Ground fault protection of equipment is a 1053. Jerry, they did not, no one has said anything. That question fell upon deaf ears. So I'm not sure. All right. You gotta love this stuff. All right, so ground fault protection of equipment is a UL 1053 device. If I go to my trusty UL 1053 standard, I need a bookmark. Remember this, table 22.1. I need a pen and I need a piece of paper. 22.1. I just grabbed this. If anybody's going to be in St. Louis, August 23rd and 24th, I would hope to see you at this event. This is the Electrical Expo, August 23rd to 24th. I'm going to be talking code changes. I'm going to be talking about NEC code changes on the 24th, all day, 8 hours of pure fun IAEI program. So you guys and gals out there should hopefully, if you're in St. Louis at the St. Charles Convention Center in St. Charles, Missouri, on those days we will be able to talk code changes with you. I'd love to see you at the event. I will be there. I think Brian Bowman, you noticed. I noticed. I think you said you were going to be there as well. All right. So now let's get back to. Oh, I got to remember this. 22.1 table. And that's on page 25. Okay, I'm saying that because I gotta come back to that because there's some important information on that table. So UL 1053 is ground fault sensing and relaying equipment. Ground fault sensing and relaying equipment. That is a very interesting thing to remember. Because the reason I say that, when you think about ground fault protection of equipment, and we said in the definition, it says a system, right? A system intended to provide protection. So ground fault protection of equipment, it could be a single breaker. Where would we see that single breaker requirement? If you think about chapter 4, when you have de-icing or snow melting equipment, and we have a requirement for ground fault protection of equipment on those circuits. A lot of people will say, well, that's 30 milliamps. It doesn't say and there's nothing in the code for that requirement that says it has to be 30 milliamps. It just says you have to provide ground fault protection of equipment. And if we go back to Annex A, is it Annex A in the NEC? Annex A, if I'm not mistaken, Annex A should have all of our standards, not just UL. It's way past chapter 9, informative Annex A. There's J. There's H, there's D, informative Annex C, and I'll tell you, in the 2023 code, informative Annex A just grew by leaps and bounds. So if I look at, they don't have Article 100. They don't have Article 100. They have it in 230. So Article 230, 230.95. 230.95 has a requirement for ground fault protection of equipment. And it looks like NFPA link is still down. Boy, I'd love to use NFPA link, but I just can't. Garage is not a dwelling unit. Second story of a dwelling unit, possibly. But your first point of connection at first disconnect is where I would be placing my surge in a dwelling. Freddie B. We will be cheering for you, Tom, on the other side of the bond. Excellent. Brian Bowman's going to help out. All right. So UL in informative Annex A is what we use to link a requirement with a standard. Now here's my issue, and I think I have to check the style manual, but my gut's telling me they're going to want to get rid of those informational notes. They don't call them fine print notes anymore. Informational notes. They're going to get rid of informational notes on UL 10 in those Article 100. I think. I'm not sure, but I like those informational notes, because here's my issue, and I can go to. There's nothing in here for Article 100 that tells me that GFCI is UL 943. It's in the informational note. Now, I don't have ground fault protection of equipment does not have an informational note that says it's a UL 1053, but in my opinion, it should, because there's nothing in Article 100. But when I go to 230, Article 230, 230.95 has ground fault protection of equipment requirements, and it's also in 210 and 215, but they don't have those in informative Annex A. Remember, we have ground fault protection of equipment requirements in 210 and 215. But the informative Annex A doesn't include that link, that connection to ground fault protection of equipment. So 210, we have ungrounded ground fault circuit interrupters in 210.8. AFCIs is in 210.12, and ground fault protection of equipment is in 210.13. So 210.13 says each branch circuit disconnecting means rated 1,000 amps or more and installed in a solidly grounded wire, blah, 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 has to have ground fault protection of equipment in accordance with 230.95. So, and there's an informational note to see 215 or 517.17, but there's nothing there in 210.13 that says it needs to be a UL 1053 device. We know that. How do we know that? If we go to 230, it ties the UL 1053 ground fault sensing and relaying equipment. So it's a UL 1053 device. In my opinion, we should have that same reference in 210 and in 215. And I would say in Article 100 as well. And I wish they had the actual section numbers, but they don't. So in any case, where else is UL 1053 referenced? I'm just looking down through really quick in informative Annex A to see if there's any other places. This is what we had to do before we had NFPA link. UL 1053. UL 1053. So here's my word of advice, that if you have NFPA link, make sure you have the offline thing checked so you download that stuff to your computer, else you are stuck like I am, searching through each of the articles for a UL 1053 reference. They got 1066. I mean, this is interesting that it's not. So 1053 is not in any of these other articles as a reference standard for any of these articles. Even 517, we know there's ground fault protection of equipment requirements in 517, and there's nothing in informative Annex A for 517, there's no 1053 reference, and there should be, in my humble opinion. So in any case, that's why we would tie it to UL 1053. Now let's talk about the equipment protection. Doesn't the code mention milliamp restrictions depending on applications such as electrical equipment in marinas? Charles, yes. So Charles, so here it is, Charles. The ground fault protection of equipment set point is mentioned in 230.95. If we go to 230.95, let's go to 230.95. Ground fault protection of equipment shall be provided for solidly grounded. So this is 1,000 amps or more, but it says the ground fault protection system shall operate to cause the service disconnect to open all ungrounded conductors of the faulted circuit. The maximum setting of the ground fault protection shall be 1,200 amps. So I know the upper limit for ground fault protection of equipment is 1,200, not 12 milliamps. 1,200 amps, UL 1053, and I can get that done with an electronic trip unit and a circuit breaker, or I can get that done. Yeah, Fred, my offline is not working either. Anyway, I can get that done with a relay, which is why the definition of ground fault protection of equipment uses the term system, because if I think about the system, thought I had, man, I thought I had them. Where is it? I don't. I had a current transformer. I thought I had a current transformer around here somewhere, a CT. I'm gonna just check my drawers here real quick and see if I have a CT. Thought I had a CT somewhere in here, and I do not have it readily handy. So I'm gonna play this one by ear. So we have a CT that is basically a donut that is around conductors. Those CTs feed into a relay, and the relay senses the current coming out of the CTs. It'll do its additions and subtractions. If I have individual CTs on each of the conductors, then I would have to do the math internally to determine the phase angles and whether or not there's current going outside the path. But most often you'll see a donut CT that goes around all of the all phase conductors, the hots and the neutral, because they all have to add up to 0. So that CT will basically take an input into a relay. The relay reads the difference of current, and if there's individual CTs, it has to do the math inside the relay. If it's a 0 sequence CT, you're just looking for the output, because it should add up to 0 and there should be no current coming out. Then I take that current into the relay, and then the relay has set points. Now, it can be a relay that has set points that I send a signal out to trip a breaker, or I can have a relay that's built into the circuit breaker, and we call that a trip unit, an electronic trip unit. And the sensors, the CTs, could be a part of the circuit breaker, all encased in itself, right? So it depends on the application. Depends on if it's a medium voltage application, low voltage application, if it's if it's a system of that where everything is separate or everything is self-contained. So I can serve this in any of those ways. Now, let's do this. I am going to do something here. All right, so there we go. So, and what I'm saying is, what I am saying is, I'm going to move this down. I don't know if this is going to work, but we're going to give it a try. Go back, do new. There we go. I'm going to try this. I'm going to see if this works. Hey, it does. So what I was just explaining is if I have phase A, B, and C. So this is phase A, B, and C. I have a separate relay. We'll call this a relay. And let's say I take a donut around each of these, and it's if I have a grounded system, we're going to call this neutral. I'd have to make sure I have a donut around each of those, and all of these would go in to the relay, and the relay would have a brain. We'll draw a brain. Does that look like a brain? That's a brain. And then I would have we'll do this. Watch this. Whoop. Tell me that wasn't awesome. So I don't have to break the grounded conductor. I just have to break the ungrounded conductor. And let's say that out of this relay, I'm going to, this is a circuit breaker. And let's say it has a shunt trip. So the relay takes the input from each of the phases, and then it tells the circuit breaker to trip when I hit the threshold. And it could be 1200 amps, could be 1000 amps, could be 800 amps. We're talking beefy current. And what we would typically want to do is make sure that the ground fault current is above that set point. But nothing in the code says it has to be. We do have in 24087 and 24067, we say on 24067, arc energy reduction, we say that, let's look at 24087. 24087, where the highest continuous current trip, blah, 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 1200 amps and above. Method to reduce clearing time. One of the following means shall be provided and shall be set to operate at less than the available arcing current. We don't say that in ground fault protection of equipment. We just say it has to be a maximum of 1200 amps. We don't say that it has to actually be set to operate on ground fault currents. That's interesting. Do we not care? Anyway, so the relay, we know that the maximum can be 1200 amps. There's nothing about the clearing times, but we know that this is GFPE, and it has to be UL 1053. That's our standard. And we know the standard reference from Informative Annex A. And I'll tell you what, Michael Hofkin, if I were you, buddy, if I were you, I would add in Informative Annex A for 210 and 215 a reference to 1053. And in 517, a reference to 1053. And any place else in the code where we have GFPE requirements, like in marinas that Charles pointed out, Mr. Peterson said, hey, look, in Article 555, we have ground fault protection of equipment and ground fault circuit interrupter. It should say, anyway, GFCIs. And what we did in there was we said, okay, so let's do that. Well, getting ahead of myself. I'm getting ahead of myself. Thank you, Michael. Any case, I'm going to get back. I you know what I did? You know, I had one of those squirrels. I had a squirrel moment. So I'm going to get back to this. That is one way to get this done, right? So let's do this. I'm going to copy this. I'm going to copy. I'm going to come down here. We're going to paste. Now what we're going to do is we're going to get rid of these I'm going to get rid of these. I think I can do, whoa, I don't want to do that. So I'm going to draw, I'm going to finish these circuits out, right? So now I have a phase A, B, and C. I've got a circuit breaker and I have a relay. Another way to get this done is with one CT that's around all three phases. And what that does, I have one input. This is what we call a zero sequence CT. And that zero sequence CT, I should get 0 amps out of it, right? I shouldn't have any current because if they're all balanced. If I have current going, if I have a neutral issue ground fault, I have a phase ground fault, and it returns back not through the zero sequence CT, then I'm going to have a differential of current. So I will trip on whatever that threshold is. So you have a couple choices, a few choices on how you arrange the sensors. Now, if I have a circuit breaker, we'll typically put the sensors inside the circuit breaker, and then on the side of this, I have an electronic trip unit. The sensors are built in the CTs. When I say sensors, I'm talking CTs. The CTs are built in the circuit breaker, and they're all wired over to the electronic trip unit. The brain then tells the device when to trip. It's all self-contained. The nice thing about this is when the manufacturer makes it, they'll put this unit through a bunch of test scenarios. And before they put it in the box, they're going to check to make sure that the CTs are the right orientation. Right? So if you look on a set of CTs, you'll see a plus or minus. You'll see which way the currents have to go through the donuts. If you reverse polarity those, you'll get a negative reading. It'll be an accurate number, but it won't be an accurate polarity, right? So what's nice about a self-contained unit, instead of something where the CTs are separate, especially in this, I have to think about the plus and the minus, the plus and the minus, the plus and the minus, plus and the minus, to make sure I have the CTs in the right direction. Or should that be plus minus? Because the current's coming back through the neutral. Anyway, I have to have all of these programmed in the right way so that I understand the polarity of the CTs to get, so when I do the math, I know a positive number, negative number, etc. And I account for all of that. Because that will change how I do my calculations. This makes it a little easier. But if you have this in the wrong configuration, this one CT backwards, and I might just have to swap the leads over here, right? Because you'll have two leads coming off there. I might have to just swap the leads, not a big deal. But I have to make sure I have those correct, wired correctly. But when I have a unit that everything is self-contained, and at the manufacturing facility, when they made this, they tested the functionality, the polarities, and all that good stuff. I have a very good chance that these CTs don't get popped out and popped back in again when it's a sealed unit during shipping, right? So the results and the when they're actually in place on a self-contained unit like that is very nice. Now, in 23095, we do have requirements that you have to do primary current injection testing on when first installed. And the reason, I would say, the driver is not necessarily a device that's all self-contained. The driver are these here, right? Because you could have those sensors installed incorrectly. So if I look at 23095, it says the ground fault protection system shall be performance tested when first installed on site. And the thought process there is I only do it when it's first installed. Why don't I have to do the primary current injection testing every 5 years? You'd have to take the gear apart, take the sensors out, and then put them back in again. And then I would say, well, now it's first installed again, right? But when you look at these installations over time, if you did it the first time, the CT is not going to come off of the bus and go back on the bus in the wrong polarity. So after the fact, I can do secondary current injection testing and other methods to ensure the electronics, and that's a 70B issue, not a National Electrical Code NFPA 70. So in any case, on first installed, I've got to do primary current injection in accordance with instructions. And again, you want to check to make sure that all of these conductors, all of those conductors are connected. You want to make sure that all of the CTs are the right polarity and you're getting the right currents back. So you're going to do primary current injection testing as part of the NEC 23095. So you're injecting current through these phases. You're injecting current through the phases. On a self-contained unit, you still have to do that. There's no allocation, there's nothing that says, hey, you know, it's all self-contained. You have a test report from the manufacturer. We know it's good, but we're still going to make you do primary current injection testing. It is what it is, but that's okay. All right. So we have these different methods. Now, we know that it's a system. We know that I'm going to have circuit breakers. I wonder if I do a search for this. Yeah, so here's an example. Here's a good picture. Whoop. So this is a ground fault relay. Now it says ground fault relay. It's ground fault protection of equipment, right? So there's your pickup points. There's your 500, all the way up to 1200. There's your maximum, 1200. I wonder, right there is 1200, okay? There's your time delay. Look at the time delay. So 23095 says, 23095 says 1000 amps or more, 1200 amps or more, and the maximum time delay shall be 1 second for ground fault currents equal to or greater than 3000 amps. So you can change the time delay. And it says 1 second. So these are probably in milliseconds. So there's your time delay. There's your pickup currents. You can push to do a test, shunt trip bypass, and then this is the toggle that goes up and down for you to reset it. And there's your ground fault. Look at this, ground fault current. So you've got a little bit of a meter here. So you have a lot of information. Oh yeah, there it is in milliseconds. So this goes from 60 milliseconds up to a second, 1000 milliseconds, which is 1 second. So and what does this curve look like? This is what it looks like. It's a hockey stick. You'll see it all the time, hockey stick. All right, now we haven't gotten to the UL standard 1053. Now, what does 1053 tell us? 1053, got to bring my cursor over here. 1053. Somehow I closed. Oh, I have a new version. Whoa, remind me later. I do this all the time. Adobe looks very much like Quicken. All right, so UL 1053, and I need to go to page 25. Page 25. And the reason I'm going to page 25 is there's a very critical piece of information: operating times. So we know there is a curve based upon Dalzie's research on the maximum clearing time based upon how much current I'm injecting, right? The maximum operating time, remember, the manufacturer or you, the engineer, right? So remember, this is my relay. So the engineer or whomever the qualified person is going to set these dials for pickup and time delay. So the standard doesn't tell you what the pickup needs to be. The standard just says whatever the pickup is. So the values for pickup on this this specific relay that we were just showing, the pickup values are established by the manufacturer. And the engineer or the qualified person who is installing this will have to pick the time delay and the pickup current. The standard, the UL 1053 standard says at, I'm going to write this down. Okay, we're going to reproduce this. Ground fault amps and time in seconds, right? So 85% of the pickup amps has to not trip. That's your first data point, 85%. So if I said 1200 amps, or if I said 30 milliamps, 85% of that pickup point, or in marinas, it was 100 milliamps. Remember, for feeders, 100 milliamps, and then 30 milliamps going to the boat. 85%, it shall not trip. 115% of pickup amps, it has to ultimately trip. So what does that mean? Ultimately trip. That means you take. So let's take the 100 milliamps. 100 milliamps. 100 milliamps. 115%. 100 milliamps. 1.15. 115 milliamps. So 115 milliamps. Or let's take 1200 amps. This is how you'd calculate it. 1200, 1.15, 1380, it has to ultimately trip, which that's not a define. So I guess you put that much current through the system and go out, get lunch, come back, and hopefully it's open. But that's just what the standard says. All right, so then the next pickup point is 150% of the pickup amps. So 100 milliamps, take 1.5 times 100 milliamps, and it has to trip 2.0 seconds. Trip. It has to trip within 2 seconds. Then, at 250% of pickup amps, it has to trip in 1 second. All right, so there's your criteria. So there's your criteria. So at 85% of pickup, it can't trip. At 115%, it has to ultimately trip. At 150%, you have 2 seconds, and then 250, you have 1 second. That has nothing to do with the heart. and protection of personnel, right? So the ground fault protection of equipment, if we look in 555, this was recently expanded. This is, I would say, the outside of 230.95 and Article 210 and Article 215 for feeders, I would argue that 555 is the first time we had because even in the snow melting, there was no milliamps. I can have a 30 milliamp device. I can have a 50 milliamp device. I can have ground fault protection of equipment trip it as long as it's less than. Because remember, what does the definition say for ground fault protection of equipment? Ground fault protection of equipment says intended to provide protection of equipment from damaging. This protection provided at current levels less than those required to protect conductors from damage through the operation of a supply. This protection is provided at current levels less than those required to protect conductors from damage through the operation of a supply circuit over current device. So if I have, if I have snow melting equipment on a 20 amp circuit, and I have 20 amps worth of conductors, my ground fault protection of equipment has to trip less than 20 amps. Could it be 10 amps? Sure. Could it be 1 amp? Sure. Could be 30 milliamps. Absolutely. There's nothing that says it has to be 30 milliamps or any specific set point for the snow melting. But then when you get to 555, we were specific. We said in 555.35, for other than floating buildings, it says the feeder has to have 100 milliamps. So, and it says listed ground fault protection of equipment rated not more than 100 milliamps shall be provided for feeders installed on docking facilities. Coordination with downstream ground fault protection of equipment shall be permitted at the feeder over current device. So 100 milliamps is the limit that's set for feeders in marinas. For shore power, it's branch circuits, receptacles providing shore power, listed GFPE, rated not more than 30 milliamps. So if I said 30 milliamps or 100 milliamps, you're looking at these clearing times, okay? And it's there for equipment level protection, not personnel protection, okay? So you've got 555.35, 555.35. Yep, NFPA link is still down. All right, so those are the limits. Those were the limits for ground fault protection of equipment. And it's definitely not 4 to 6 milliamps, and it's definitely not as fast of a time. We know that the GFPE is going to be based upon. So here's another device. This is a circuit breaker. Equipment protection only. Equipment protection only. That's a 20 amp circuit. Right? Let's look at a few others. Here is type GF. Look at that. It says EP, not ground fault protection of equipment. But 10K max, safety instructions, ground fault, equipment protector, equipment protection only. Oh, here's a larger. This is a unit that goes on the load side of a circuit breaker, and it provides. Look at your ground. There's your multipliers, 0.03 to 10, and then instantaneous to 1 second. This is 125 amps. Hey, Ryan, good to see you, buddy. We're talking ground fault protection of equipment here. That's the same unit. What's this one? Same type of unit. So I was just looking through some of my images. Here's another ground fault. 30 milliamp. This one says 30 milliamp ground fault trip level. So that one specifically calls out 30 milliamp. But that's not driven by a standard. UL 1053 just says the trip times. All UL 1053 is telling me are these trip times. They're not giving me the threshold pickup. That's determined by the manufacturer. And if it's a relay, the manufacturer will give you a series of set points. The qualified person would have to set the relay. Sent notice to NFPA, non-functioning NFPA link. Thanks, Fred. I appreciate it. And then we've got 555 that has some ground fault protection of equipment requirements. We've got 240, Article 240, 230, 215, 210. We've got our snow melting equipment that has to have GFPE. Now, here's another thing that that you could do. We have 250.122. 250.122. I've had this discussion too with I had a customer who did not. If you look at 250.122, what does it say? 250.120, size of the equipment grounding conductor. Increased in size. If ungrounded conductors are increased in size for any reason other than as required in 31015B or C, 31015B or C, those are your adjustment factors. I'm just going to read those two. I'll just give you the titles. 310.15 are your ampacity tables. And then this includes your adjustment factors for more than one current carrying conductor, and B is your ambient, and C is your adjustment factors for number of conductors in a raceway. So if for other than that, so for example, you were the only size you had on the let's say that it was the only size you had on the truck. Or let's say it was for voltage drop, whatever the reason. If it's not 31015B or C, then wire type equipment grounding conductors, if installed, shall be increased in size proportionally to the increase in circular mill area for the ungrounded conductor. But there is an exception. Equipment grounding conductors shall be permitted to be sized by a qualified person to provide an effective ground fault current path in accordance with 250.4A5 or B4. So if we go to 250.4A5, 250.4A5, this little bit of info may save you a lot of money. 250.4A5, effective ground fault current path. Electrical equipment and wiring and other electrically conductive materials likely to become energized shall be installed in a manner that creates a low impedance circuit and facilitating the operation of the overcurrent device or ground detector for impedance grounded systems. So if I am on, I don't know, 250 amps worth of conductors, I have a 250 amp breaker, but I had to put a larger conductor in because that's all I had on the truck. I'm going to leave the breaker the same size. Then I would have to increase the equipment grounding conductor size. But all I have to do is make sure that the ground fault current trips the breaker. And the ground fault current can't be less than 250 amps. I don't have to trip in the instantaneous region. I can trip as long as I trip the circuit breaker. Or if the ground fault current is less than 250 amps, I could put ground fault protection of equipment and trip and provide the protection just as long as I clear the overcurrent device. It says it shall be capable of safely interrupting the maximum ground fault current likely to be imposed on it from any point on the wiring system where a ground fault current, okay, the earth shall not be considered as a ground fault path. So that's the first reference. The second one is 250.4, that's A5, or 250.4B4. And 250.4B is ungrounded systems, which if I have an ungrounded system, then it's path for the electrical equipment wiring. So 9 times out of 10, you're going to have a grounded system. So all I need to do is calculate my ground fault current and make sure that it trips the breaker. Doesn't have to trip in the instantaneous region. I've heard people say that before. Oh, you have to trip in the instantaneous region. Not true, because all it has to do is trip the breaker. It's in 250. It's in 250.4A5. 250.4A5 just says, shall be installed in a manner that creates a low impedance circuit facilitating the operation of the overcurrent device or ground detector. So if I have, for impedance, so if I have an overcurrent device that has ground fault protection of equipment in it at 30 milliamps, I don't have to increase the size of the equipment grounding conductor. If I have a 250 amp breaker and my ground fault current is greater than 250 amps, it's going to trip the overcurrent device. I don't need to increase the size of the equipment grounding conductor because all I need to do is trip that breaker. So there's another way that you can use, or that is a way that you can use ground fault protection of equipment to help maybe get you out of a jam. All right. So we talked about a few locations in the code where ground fault protection of equipment is required. We talked about the fact that it's a system and it differs from GFCI and from special purpose ground faults. So special purpose, I have to say that because ground fault circuit interrupter, special purpose, it's a new device that's recognized by the code. Its definition is a device intended for the detection of ground fault currents used in circuits with voltage to ground greater than 150 volts that functions to de-energize a circuit or portion of a circuit within an established period of time. There's the established period of time. When a ground fault current exceeds the values established by a Class C. So they have an established period of time and a value established for a Class C or D or E device. GFPE doesn't have an established value based upon the standards. The manufacturer determines what that standard value, established value is, and UL 1053 just says, here's how fast you need to trip. But UL 1053 doesn't tell you 30 milliamp, 100 milliamp, 1,000 amps, 2,000 amps, 1,200 amps. It doesn't tell you any of that. It just tells you the clearing time response. I found the special purpose, Joseph. Found the special purpose. It's right here in the code, chapter 1 on page 42. And so the difference is ground fault protection of equipment. The manufacturer tells you what the pickup set points are. You can set, in many cases, set the value of pickup, and the UL standard just says, look, if it's 85%, it can't trip. If it's 115%, it has to ultimately trip. If it's 150%, you got 2 seconds, and if it's 250%, you got 1 second. And of course, UL 1053 has a lot of other little things that you need to follow, but that is where we're at with 1053. Ground fault protection of equipment devices. All right, so hopefully we spent an hour together. We spent an hour and 4 minutes and 19 seconds, and we will continue, but hopefully you got something out of today. You got something out of today's discussion around ground fault protection of equipment. Take a look at the code book. Take a look at the next device that you may install called ground fault protection of equipment. And hopefully you can apply something that we talked about today in those applications. All right. Thank you, Mr. Wages, Fred B., Michael Hofkin, Charles Patterson, Nihad El Sharif, Brian Bowman, the Brian Bowman. We'll see you in St. Louis, Missouri. Willie Snyder, Jerry O'Connor, and everybody else who joined in. Thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember to stay safe and please stay healthy, and we'll see you next week.